Gold. It's one of Earth's rarest and most coveted treasures. It has fueled empires, sparked wars, and built economies. But have you ever wondered, how does gold make its journey from deep beneath the Earth's crust to the gleaming bars stored in vaults or the jewelry on our wrists? In this documentary, we take you deep into the world of gold processing, from extraction to refining, uncovering the science, technology, and human labor behind every ounce of this precious metal. This is the untold story of gold, from ore to pure. Through volcanic activity and tectonic pressure, gold migrated through the crust, eventually becoming trapped in rock formations we now call ore bodies. But finding these deposits is no simple task. Once a gold deposit is confirmed, the next phase begins: mining. There are two primary methods of gold mining: open-pit mining and underground mining. Open-pit mining is used when the gold is near the surface. Giant machines remove layers of rock and earth to expose the ore beneath. Underground mining, on the other hand, is used for deeper ore bodies. Miners create tunnels and shafts to access and extract gold-bearing rock. Explosives blast the rock apart. Then, it's loaded onto trucks or conveyors to be transported to the surface. And now, the real work begins, turning that rock into something valuable. At the processing plant, the ore first goes through crushers, powerful machines that reduce it to smaller chunks. Next, it's passed to ball mills, giant drums filled with steel balls. These mills spin continuously, grinding the ore into a fine powder. Why such fine grinding? Because the gold is locked inside the minerals, and it must be liberated before it can be extracted. Once we have the powdered ore, it's time to extract the gold. But not with picks or pans. We use chemistry. There are two major chemical methods to extract gold: cyanide leaching and gravity separation. In most modern gold mines, cyanide leaching is used. Here's how it works. The powdered ore is mixed with water to form a slurry. Then, a dilute cyanide solution is added. Cyanide binds with the gold particles, forming a gold cyanide complex that can be separated from the waste rock. The slurry passes through tanks where activated carbon attracts the gold cyanide molecules. Once loaded, the gold is stripped from the carbon in a process called elution. Now that the gold has been separated chemically, it's time to turn it into metal. The gold is mixed with flux, materials like borax or silica, and placed in a furnace. At over 1,000 degrees, impurities separate and rise to the surface as slag. What's left is molten gold. This glowing liquid is poured into molds called Dore Bars, a mix of gold and silver. Though impure, these bars are the first solid form of gold produced from the ore. But we're not done yet. To reach pure, 24-karat gold, it must be refined. Refining is where science and precision meet. In the Miller process, chlorine gas is blown through molten Dore. Gold forms solid particles and separates from other metals. In the Wohlwill process, gold is electroplated using a gold anode and electrolyte solution. This produces gold that is 99.999% pure. The result? Gleaming, high-purity bars, ready for the market. Each bar is weighed, stamped with purity, and registered. Some are sent to central banks, others to jewelers or investors. Gold is more than just metal. It's a symbol of power, beauty, and permanence. The next time you see gold, know the incredible journey it took to get there.